Hello, and today I'm going to teach you how a panel data set is treated. I have already a panel data set here. This is the panel data set here in the sheet 1. I have data of 4 companies: General Electric, General Motors, the third company is US Steel, and the fourth is Westinghouse. These are the 4 companies that I'm going to use for the panel data, and these are the number of years. Number of years are from 1935 to 1954. This is the time period for which I'm analyzing every cross section of this data. This variable, this is our dependent variable, real gross investment. This is our independent variable, value of firm, and this is our another independent variable, capital. You will notice here that I have made the ID variable manually in Excel. You can also make this variable or generate the ID for this company's data by giving the command ofegen instead. But however, I will use this ready-made ID variable. Now select the whole data, go to data, open the data editor, paste the whole data here, close the data editor, and all of your variables will show here on the left hand corner of data. Now, before going further into data analysis of the panel data, you should tell Stata that it is dealing with the panel data by command tsset id years. Here you can see that id is strongly balanced. It means that we have balanced panels. Balanced panel means that there are no missing observations for any of the panel, and there is not a situation where one panel has, let's say for example, 60 observation and another panel has 50 observation. So this panel data have strongly balanced panel ID. Time variable is years and time period is 1935 to 1954. You can also give command xt test xt set id years. It will give you the same result. One thing more I would like to say that this id here, it represents the number of cross sections, while these years, these represent the number of time periods. Now, before going further directly to the panel data analysis, I'm going to run some diagnostics. And before diagnostic, I would like to save the file and to save the results. Log begin. I will give it the name results and save it on my desktop. Now, from here on, first of all, I'm running a simple regression on the real gross investment, value of firm, and the capital. After that, I'm checking the problem of multicollinearity to the variance inflation factor, VIF. From the figures you can see that none of the values of VIF is greater than 10. not even greater than 5 and not even somewhere between 5 and 10. Therefore, there is no multicollinearity problem in the data I am using for panel data analysis. Similarly, I can check for the heteroscedasticity through a test. Well, I have run the Breush Pagan test. The data is homoscedastic, it's the null hypothesis, and the probability value, the p-value for the Breush Pagan test clearly show that it's greater than 0.05, and it means the data is homoscedastic. But let's see what the White generalized test for heteroscedasticity suggests. I am test White. Well, let's see here. Here we are having the problem. You can clearly see that the results are less than 0.05, which means that it is going to reject the null hypothesis of the homoscedasticity, and it means that the data is heteroscedastic. There is difference between the results of the two tests for heteroscedasticity. Let's see why are these results like such. This can be due to the normality problem. Maybe my data is not normal. Now let's check the normality for the data first. SK test Well, you can see from the probability values that none of my variables is normal. All the variables are non-normal. Now, if I try to make it normal, then let's see what the Breush Pagan test results suggest then. RVP plot, where you firm. Well, let's delete these values above 5,000, let's say, this area. Specifically, these observations lie too much outward and far away. If I delete these observations, drop if value of firm is greater than 5,000. 3 observations are deleted. Only 3 observations have been dropped down. Now let's check again the normality for this variable. Still, it's below 0.05. Let's check it. Let's drop some variables more. It's greater than, let's say, 4,500. 7 observations are deleted. Let's get again the normality test for the same variable. Now we can see that the data became normal. The probability value have gone up to 0.1044, which is simply greater than 0.05. Data for this variable has been made normal. Now let's go for the other variable. Capital. Well, if we delete values greater than 600, let's see what does happens to the results of normality test. Then drop if, let me check whether, yeah, 700. Drop if it's greater than 700. 7 observations are deleted. Again run Stevens Scott-Ross's test for this variable as well. Well, again It's less than 0.05. It means that the data is not normal yet again. Drop some more observation. Let's say 600. 5 observations are deleted. Again, we can go for the normality test. Now you can see that this variable has also become normal. The probability value for the skewness cutoff that in this case is also greater than 0.05. Now again regress these variables and check the multicollinearity. Again there is no multicollinearity. Now check value for the Breush Pagan test. It's 0.0225. Now check what White test suggests. Now both the values are almost equal and both are suggesting the same results, that the data is heteroscedastic. Now after running the panel data analysis, we will also take care in the final model for this heteroscedasticity problem as well. But you can see from both the values that they are almost same and suggesting the same result. From this we can conclude that the problem between the difference of results was due to the normality problem. Now we can go for the panel data analysis. First of all, we have to check whether the simple OLS, the pooled OLS, is the best model or not. For that, first of all, we have create dummies. We have to create the dummies, and command for that is tabulate id gen companies. Here you can see 4 dummies are created for the 4 companies that I am using for my analysis. Now, through word joint significance test for these dummies, I have to run the regression for these dummies. Dependent variable, independent one, 3, this company, this company. Now notice that I have used only 3 dummies instead of 4. I have used 3 dummies in order to avoid the dummy variable trap, simply in order to avoid the situation of perfect linearity. That's why I have used the dummy variable. And moreover, you can also say, and in fact it is, you can say a fact, that if you use too many dummy variables, you will fall into dummy variable trap, and you will also fall into the degree of freedom problem. Therefore, I have used only 3 dummies. This is the regression of dummies. Now, we can use the test palm command, the test palm command to check for the joint significance of these dummies. If we have significant results, it means that the dummies are not equal to 0 and they are fixed effects in this data set, and we will not use the pooled OLS then. Let's check test palm. Well, you can see from the p-values that it is less than 0.05, which reject H0 that these dummies are equal to 0. So they are not equal to 0, and it means that pooled OLS is not a better option in this case. Now we have to check between the fixed effect and the random effect, that whichever is best on my data. For that, go for the panel regression of XT-reg, dependent variable, independent, another independent, and for fixed effect, add the fixed effect. Now store the estimates of this model by typing the command estimates store fixed. Now run the random effect model. Xtreg all variables random effect. Now store estimates of this random effect model as well by typing the command estimates store random. Now to get the best model between the fixed effect model and the random effect model, you have to run the Hausman test, and for that the command is Hausman fixed random. In simple terms, the null hypothesis for this test is random effect model is better than the fixed effect model, and you can see from the p-value that the null hypothesis is accepted, which means that random effect model is better than the fixed effect model. Now, as from the heteroscedasticity results, sorry, from the heteroscedasticity results, we concluded that the data is heteroscedastic and they can affect the results of the random effect. So we can run again the random effect model but with robust standard errors. Xtreg random effect, because the best model selected was the random effect. Robust. Robust analysis controls for the problem of heteroscedasticity, and this is the results for your best model. One thing more I would like to say that you can also run the Lagrange multiplier test in order to run the comparison between the pooled OLS and fixed effect. And that Lagrange multiplier test command is xtest0. Sorry, it's for between fixed, it's for between pool and random effect. Now xtest0, this command can be used to check for the comparison of pooled OLS versus the random effect. Although it's not necessary in this case, because we have already checked that pooled OLS is not a good model or the best suited model in my case, because the wall joint significance test showed that. But if anyone runs the three comparisons, then you can run the comparison between random effects and pooled OLS like this. The null hypothesis for this is pooled OLS is better than random effects, and this hypothesis has been rejected. 0.00. So the best model in my case is the random effect, and I have run that random effect model with robust standard errors in order to take care for the heteroscedasticity problem. And now I want to save results. Log close. These results are saved. You can get these results exactly in the same form as they are in Stata. Copy this address, go to File, View, and paste it here. These are the results. Select all, copy them, and go to Notepad. Now paste these results in your Notepad here. These are the same results you can see as they were presented with commands in Stata. You can save them with name of results 1, let's say, and I save them here in the desktop. Now, this was all with the panel data analysis from my side. In case of any query, you can write to me on my email as well. Take care.